We are going to have some time afterwards for some more networking questions and discussion as well, but without further ado, I want to invite our next speaker to take the stage, Dr. Ed Bork, and he's going to be discussing the state of current research on soil carbon in grasslands. So with that, thank you very much.
Good afternoon, everyone. See, I came in a little later because I was meeting with some folks out in the lobby. We're planning already the next research project. So, and I could tell by some of the questions Brian was getting that there's probably going to be some interesting questions after this as well. So when Graham had contacted me and asked me to talk a little bit about some of the work that we've been doing, at the University of Alberta, twofold, I guess. First of all, we're working on a whole suite of different environmental goods and services. Carbon and greenhouse gas fluxes happens to be one of those pieces. So I'm going to concentrate mostly on carbon today, but I'm certainly happy to take any questions that you may have on some of the other pieces as well. Oops. Sorry.
Did it go? Okay, hang on.
Technology.
Try the other side.
No.
No, okay. Hang on, let me hit page down at least. No, that's 2 seconds.
Did your
here.
computer give it a virus?
No, but we are having trouble here this afternoon. Hang on.
Yeah, probably. You'd be happy to know, Barry, I pulled out some of the slides to try to fit it in.
Not liking it.
Always just use the arrow keys.
Yes. So hang on here. I gotta get to, what did you do here, Graham? 10 seconds, folks.
Should have taken a bathroom break.
Oh yeah, let's take a bathroom break until we get the share here.
There you go.
Oh. Because what you see here is different, and it's not moving. So. All right, come on, Zoom, do what you're supposed to do. No, I don't want to do that.
Otherwise, you're going to end up when that's
Yeah, yeah, I don't want to do that. Yeah. All right.
Cancel.
Yeah, cancel. All right.
So all those links will be toasted.
Why won't it let me do that? There's our meeting controls.
It did work.
Huh?
It did work for a second.
I know it did work.
Let me try it again.
Yeah. But I got to change the screen share. That's smart. Sorry, guys. Oh, fart. What didn't it share? Yeah, let's take 5 minutes.
Sorry, may as well take a 5 minute
Yeah,
break.
let's take a 5-minute break for those of you who want to grab a coffee.
Stretch their legs.
We're going
Until we
to
get this figured out.
You bet. So please take 5 minutes and we'll be back at 1:45.
Why didn't it?
Thank you.
because that's what's coming
Yes.
online. I don't want to end the meeting.
Canceling the screen, is that a touch screen?
Yes, but it's from my end. This
Oh,
is
you're
what I
projecting.
see.
So when we advance it, it's advancing there, but it's not advancing
Yeah.
there?
Yeah,
So it's advancing for folks online, but not for the people here in the room.
which I don't understand.
I can turn this off, and turn it back on again.
What's up there? That's what's, don't do anything here. Mute my audio, stop radio. No, we don't want to do that. That's the meeting control.
Do you want to reload my presentation?
No, it's me running this video. It's not your presentation.
Okay.
So. Sorry, folks, we got a hiccup with our video here, so bear with us. I don't want to start Zoom. I don't want to. So there's that. This desktop, this desktop. No, it's not gonna work. So why can't I? There we go. You share.
You don't have the pause on or something at the top, do you?
But if we go to and I share, cancel that. So now run your, see what happens. Does it move it?
No.
No. What about the other side? Okay, so what happens if I go page down? Neither. Page up. Okay, let me. I'm going to stop share. And I am going to. Here's your PowerPoint. I'm going to actually share that one. So it's this one shortened?
Yep.
All right. If you go slideshow, that works.
Yeah.
Okay.
So we just have to reload it?
Or something along those lines.
Okay.
So now I got to make sure. Now where's my?
Sure. We can dig around wherever we need to.
Okay. Again, before we go, just hit yours again to make sure it moves. Does it move?
No, now it stopped again. So what did you do just now to make it?
Nothing, other than reloading it.
Nope, stopped again.
Okay, then I'm gonna have to.
So it worked initially and then shut down again.
So I'm gonna have to manually move it for you.
Okay.
You can move those ones out?
Yeah, I can, so if I go, yeah, so I'll just manually
Okay.
move and you tell me when you gotta
That's
move
fine.
it.
Yep.
So good.
Good. All right, I'll let you. Okay. We have everyone back? Okay, I think we have our technical difficulties remedied, hopefully. So as I was saying, basically I started this research in 2012, basically with support initially from the Alberta Livestock and Meat Agency. Our initial study was basically looking at what we call the carbon benchmarking study, which was basically to quantify the size of the carbon stocks in grasslands in Western Canada, specifically in Alberta. And then we expanded that work to look at some more detailed mechanisms as to what may actually regulate the size of these carbon stocks, the amount of carbon, and some of the important vectors that may be responsible for accumulating carbon within these systems. So I'm going to cover snapshots of a whole bunch of these pieces today. And I'm not sure how much time you're going to give me, Graham.
I get you in an hour with questions.
Okay. So just to put into context, Alberta's got a little over 20 million hectares of farmland, so it's a lot of land area we're talking about. Over 9 million hectares of land that's either in native grassland or some kind of perennial forage, tame forage, introduced forage. So we're talking about a really large footprint, and yet when we talk about carbon storage, carbon valuation, that's the area that we don't necessarily have a demonstrated carbon market for, or at least a demonstrated system in place to reward producers for storing and enhancing that carbon. So that's the area that we've been focusing on. Okay, just to again put it into context, beef production is the single largest agricultural commodity in the province of Alberta. More than half of the farms have got beef cattle. 38% roughly of all farm income originates from beef cattle. So it's a very big economic driver. And despite that, I would argue if you compare the relative returns from beef production, at least in comparison to annual crop production, I happen to also live on a mixed farm northeast of Edmonton, and I've seen what those returns have looked like since 2002 BSE. And certainly on average, our crop component of our farm has been outdoing the beef side for most of those years. And this is one of the reasons that I'm very interested in trying to understand how do we increase the value added from what those beef operations are doing, which in large part revolves around these EG&Ss that I'm going to be talking about. Okay, so what are the options for the cattle industry? Again, this is big picture thinking. How do we increase the revenue? Well, one of them, and this has been worked on by a lot of different research groups. One of them is to reduce production costs, for example. The Lacombe group worked for many, many years looking at swath grazing, extending the grazing season in the spring, trying to reduce overwinter costs, since that's the lion's share of the cost that many beef producers incur when they're trying to run a sustainable system. The other one is increased production efficiency. So I've been working with Graham Plastow and of course others like John Becerra are doing lots of work looking at feed efficiency, trying to figure out how do we get more weight gain out of feeding the same amount of feed. So those are all important, but I would argue that we're by only focusing on those for many, many years, many decades even, that we're kind of ignoring the ecosystem goods and services, which are the flow of benefits that are provided by these land areas to all of society that up until now have been undervalued. Okay, so when we talk about EG&Ss, most of you are aware of this, but we'll just throw that out there to make sure we're on a common playing field. So these are benefits provided to grasslands to all of society. So it doesn't matter whether you live on that particular tract of land or whether you live in Toronto or Edmonton or Vancouver or Halifax, you're going to benefit from many of these things. So when we think of flood mitigation, for example, water storage, water purification, if you look at the city of Calgary, for example, the significant flood event of 2013, when that event happened, now there's a lot of interest in understanding how do they modify watershed management upstream to mitigate and minimize those types of events downstream. course, in some cases, they may not be able to when it's a 1 in 500 year rain event. Other ones include pollinators, biodiversity, and habitat. Those might include species at risk. It might include consumptive wildlife species, or it might include species that we might not think about as important wildlife species, but nevertheless have a really important role. When you look at pollinators, roughly 80% of the world's food supply is supported by some degree of pollination, and therefore that's a really important piece. Out of all these EGNSs, forage production is the historical EGNS that most people think about. The roots of my discipline of rangeland management, range science, are rooted in how much forage are we producing, how much beef are we producing, how can we increase that level of production. These other EGNSs, including carbon and greenhouse gas uptake or storage or mitigation, have been really growing in importance and understanding. And there's an appetite not only among the beef industry and beef practitioners, but also the public at large in understanding what is the relative footprint of different agricultural activities, including beef production, on all of these other things. And I would argue that the beef sector is one of those industries, ag industries, that's most compatible with maintaining all of these other EGNSs, the ones outside of forage production, and we need to do a much better job making that business case. Okay, so I'm going to concentrate on this one, carbon and greenhouse gas uptake, since that's the one Graham asked me to come and talk about today. Okay, so carbon dynamics, just to make sure that we're all thinking about exactly what's happening with the carbon cycle. The reality is all of our agro ecosystems are cycling carbon. That's what they fundamentally do. Photosynthesis, so plant growth, basically removes CO2, locks it up in some kind of plant biomass, and then that plant biomass, through respiration and decay, slowly returns that carbon to the atmosphere. So that's ongoing year after year after year. Where we happen to live here in Western Canada, we have a relatively short growing season. We are in a temperate environment, which means we have very short bursts of plant growth, 3, 4, 5 months, 6 months if we're really, really lucky, which means we have basically net assimilation of carbon, if you like, for a short period of time, and then our ecosystem sleeps for the rest of the year, in which net respiration or decay is occurring. So every year we go through that kind of oscillating cycle. And I want to be clear that anything we do to the system to increase photosynthesis and therefore biomass production will increase the amount of carbon stored. So if you look at a plant community and you conclude that it's water limited, or it's nitrogen limited, or it's phosphorus limited, and you add nitrogen or phosphorus or water, and you overcome that limitation, you increase plant growth, of course you're going to increase carbon assimilation. That's true. So there are studies out there that say, hey, if we fertilize, we can sequester more carbon. That's true, but I would argue, being more of a holistic thinker, that you also need to take into account the energy inputs that you went through in order to produce that added or generate that added fixed biomass within the system. So if you're going to do a full net accounting, you have to look at everything together. And I don't think we always necessarily do that. Sometimes we strictly report one piece. Okay, so why soil carbon? So if you look